You're watching Orbit Types by NASA Earthdata. There are 6 orbit types we will cover in this video: geostationary, geosynchronous, polar, walking, sun-synchronous, and Lagrange. A platform in geostationary orbit stays positioned at the same location over Earth, directly above the equator, with 0 inclination. Check out the Tropospheric Emissions Monitoring Pollution, or TEMPO instrument. TEMPO is a grating spectrometer that is sensitive to visible and ultraviolet wavelengths of light. It sits aboard the Maxar-built Intelsat 40E satellite and monitors major air pollutants across the North American continent every daylight hour at high spatial resolution. TEMPO provides hourly measurements of ozone, nitrogen dioxide, and other key elements of air pollution spanning the Atlantic to the Pacific and from the Yucatan Peninsula to the Canadian oil sands. A platform in geosynchronous orbit moves at the same rate of the Earth's rotation, but can be at any inclination. Let's use JASON 3 as an example platform with a geosynchronous orbit. JASON 3 can measure significant wave height, sigma naught, and dry and wet troposphere and ionosphere, which can be used to calculate sea surface height anomalies, and total electron content. Bet you can't guess where the polar orbit passes? That's right, a platform in the polar orbit passes over or close to both north and south poles, while Earth rotates, allowing observation of the entire surface. SUMI NPP has a polar orbit. Have you heard of it? The SUMI National Polar Orbiting Partnership platform collects Earth observation data to help scientists better understand climate trends and global biological productivity. Its 5 instruments take measurements related to atmospheric composition, carbon cycle, ecosystems, and biogeochemistry, climate variability and change, water and energy cycles, and weather. SUMI NPP was the first satellite in a series designed to provide critical data to improve short-term weather forecasts and increase understanding of long-term climate change. A walking orbit is an orbit path that moves over time as a result of naturally occurring gravitational forces. Landsat 9 is designed to have a walking orbit. As part of this historic Landsat series, which launched in 1972, Landsat 9 extends the longest record of Earth observation and provides reliable data to monitor change in Earth systems. With each new mission, Landsat's data record gives researchers the chance to identify and document historical trends over more than 5 decades of consistent and continuous imagery. Here's NISAR, here to demonstrate a sun-synchronous orbit. A sun-synchronous orbit is a near-polar orbit where the platform passes over the same location at approximately the same time of day. NISAR observations from the joint NASA-ISRO Synthetic Aperture Radar platform provides new opportunities for monitoring Earth's surface, from cryosphere to sea level, measuring changes as small as a centimeter. The last orbit type we will cover is the Lagrange orbit, which is located between the Sun and Earth using the gravitational forces of both bodies to maintain an orbit around the Sun at the same rate of Earth. DISCOVER, or the Deep Space Climate Observatory, is an excellent example. A partnership between NASA and NOAA, DISCOVER orbits about 1 million miles from Earth in a unique location called Lagrange Point 1, allowing it to hover between the Sun and our planet and making it possible to monitor solar wind activity in real time. Having the ability to identify space weather events early is critical to protecting public infrastructure systems such as power grids, telecommunications, aviation, and the global positioning system, all of which can be significantly affected by solar storms.